So when it comes to oral tradition, this is the embodiment of the knowledge systems that have been generated and passed down over time. I mean, you think on the grand scale of human history, written languages are very recent phenomena, and not that many cultures in the world really have written languages. But oral tradition is the way of transmitting vast amounts of information across generations, and it has to be done through memory. Now, our brains have evolved to necessitate or to link memory to place. It's something called the method of loci, and the explanation for this, the Western scientific explanation for the method of loci, was the topic of a Nobel Prize in medicine and physiology a few years ago. It's the way that our brains have evolved to link memory to place, and a place can be a lot of different things. It can be a physical location, it can be an object, it can be a color, a texture, a landscape feature, it can be a star. And ways that that information is encoded is through story. Story is a way you can take multiple levels of information and put it into a narrative. And these narratives need to be something that is memorable. The narratives often include superhuman feats of strength, humans morphing into animals, sex, violence, all those types of things, because they are memorable. And the oral traditions are very pragmatic. If they're not, the knowledge being passed down through those traditions is not going to have any practical application. So these oral traditions are developed, they're passed down through story, they're passed down through song and dance, through social practices, and through craft engineering. All these types of things embody ways of passing down information mentally through oral tradition. So in the context of the work that we've been doing for the elders, they say, look, we're a people of culture, but we're also people of science. And one of the layers of that information is a very scientific layer. It explains the function of the world around us, how it originated, how it works, and how you can apply that information for practical use. So rather than thinking about oral tradition as myths and legends or fairy tales, which are often intended to degrade or delegitimize them, we have to think about them in new and different ways. And one of the challenging things about orality is understanding how long it can last. Through the last couple of hundred years, the idea of oral traditions, they don't last more than a couple of generations. I don't know how the hell that works. How can you have these knowledge systems with all this information being passed down if it doesn't last more than a couple of generations? But it's been bringing up an interesting point. Well, how long can these oral traditions survive? How long can they last? And we're finding that they can last for quite a long time. So to give some examples, part of what we're doing here is looking at the archaeology of orality. How can we date oral tradition? That's very difficult. Because oral tradition isn't always meant to be literal. There's lessons in oral tradition, these knowledge systems. There is stuff that's meant to be symbolic. You know, it's not always meant to be literal. But there are natural events that are described in oral tradition that can be dated. And it's important to remember and recognize that oral tradition is not static in time. It is dynamic. With new events, new information can be encoded into oral tradition. As the climate changes, as the landscape changes, as the stars themselves change, that knowledge also has to change to adapt to it. So in the sort of technical aspect of what we're looking at, the archaeology of orality, we're trying to look for two things: the terminus post quem and the terminus ante quem, the limit before which something can occur and the limit after which something can occur. I should just switch those around, sorry. But it gives us boundaries to look at how we go about dating these. If it's something like a solar eclipse, these are pretty rare events. From any given one location, they only occur every 300 or 400 years. And of course, a solar eclipse only lasts for a few minutes, the aspect of totality. So the terminus post quem and the terminus ante quem of a specific eclipse event is very, very specific. We can narrow that down to literally a few minutes. But if you're looking at something a bit broader, that can be more of a challenge. For example, Taticampere, which is the Henbury meteorite craters in the central desert. This is a crater field from a small asteroid that came barreling into the atmosphere 4,500 years ago. It fragmented from ram pressure, broke apart, created about 16 impact craters across the landscape.
And that is recorded today in oral tradition. The literature people talk about how this formed when an evil spirit, as they described it, came down from the sun, set the land on fire, hit the ground, created these gigantic holes, killed people for breaking traditional law, and filled them full of iron. And this crater, as you can see here on the middle of the screen with the trees inside of it, because a creek drains into that after rain events, the crater will fill up with water like a pond. The people back in the early 1900s said, we don't go there and collect water because our traditions say if we do, the fire devil will come back and fill it with iron again. There's a very clear indication of that oral tradition being passed down since its formation. But when did it form? Well, you can use scientific means for testing that. You can look at isotope ratios or things of that nature. I don't think Henry's been dated since about the 60s or 70s, but when it was estimated to be on the order of 4,200 years. So that gives us a tremendous antiquem, roughly. We have to put rough boundaries around that. Some of them go back even further. If you go up to the tablelands of Queensland, south of Cairns, is Lake Eacham, Lake Barine, Yakiramu. These are formed from volcanic means or volcanic crater lakes. So magma underneath the surface heated the groundwater, which superheated and exploded. And there's lots of traditions that talk about the ground rumbling and shaking, the ground exploding and then creating these giant holes. And some of them have been dated between 10 and 17,000 years ago, but the most recent date is around 9,000 years. So we're getting some inclination. These oral traditions can last for a very long time. Oral traditions that go back more than 10,000 years are a bit more rare, but they do exist. And today is one of the examples of where we're going to look at that, not using one line of evidence, but using two lines of evidence that are independent but fit together exactly perfectly. So what we're going to focus on is Tasmania. So what I've done here is just provided a map showing there's tremendous diversity in languages and cultures across Tassie. And each one of these colored spaces represent different community lands. And prior to colonization, there were about 5 major languages within Tasmania. Now, the history of Tasmania is not a pretty one. There was outright genocide in Tasmania, as there was across much of Australia, but in Tasmania, it was extremely severe and extremely swift. There was also tremendous Aboriginal resistance due to this period called the Black Wars. So Tasmania, as everybody knows, used to be called Van Diemen's Land. And in the early 1800s, colonization hit Tasmania pretty hard. One of the real challenges that came from this was the early scientific bodies, the early anthropologists and ethnographers went into Tasmania, and they considered, very falsely, Tasmanians to be on the lowest rung of humanity, barely above that of animals, and were treated as such. There was a period where the government decided that the colonization and exploitation of Tasmania was of prime importance, and to do that, you had to get rid of all the people. So they tried a couple of different ways. They tried what they called a friendly way, and they tried a much less friendly way. The quote-unquote friendly way was the friendly mission. And this was led by the Quaker and religious man, George Augustus Robinson. From the period of about 1829 to 1830, he began this task of befriending a local group of Aboriginal Tasmanians and going around the island and very gently convincing the people to leave their traditional lands and go off to other parts of Australia, most of the islands in the Bassian Strait. This proved to be quite a challenge because people didn't want to give up their homes. Why would they? Of course. And there were a number of horrific massacres that were happening where people were outright murdered in cold blood, and some stories that will absolutely make your blood curdle. It just is pretty disgusting what happened in Tasmania. But during this period of Robinson's quote-unquote friendly mission, he did wander, go all over Tasmania, trying to work with the different communities to
to convince them to leave the island. And when he did this, he kept these detailed notes of what he learned from the people on his team. And he recorded those in quite a large database that sat in the Mitchell Library for a number of years in Sydney until about 1960s, when a biophysicist named Brian Plomley decided to go through and transcribe all the original handwritten notes and publish them as a book called The Friendly Mission. So that was published in 1966, and it's quite a fat book. I should have brought my copy in. It is one of the very, very few sources of information we have about traditional Tasmanian Aboriginal life, language, culture, and traditions. It's extremely fragmented. What is there is just the tiniest scrape of what once remained, or what once was, I should say. And that includes a pretty significant degree of star knowledge. But one of the big problems out of that is not only is the star knowledge as described very simplistic, but neither Plomley nor Robinson had very much formal training in astronomy. And a lot of what they recorded through the eyes of an astronomer, you can see plainly they got wrong. So they're really kind of trying to figure things out as they're going through. And we're going to talk a bit about that today, because what we're left with are two main sources of information. We have the journals of Robinson that were translated and analyzed by Plomley. And then we had something else from a Quaker family, Francis Cotton. So Francis Cotton, and there's a lot of contested stuff around the Cottons. They were Quakers. They apparently knew some local Aboriginal people, one man in particular that they said was named Timler. They learned a bit of traditional star knowledge from and recorded that down, or they had that in this sort of family oral history. Now, that information, those stories that they had learned from Timler and others have been passed down in the family over a number of generations and eventually written down. Now, they were written down and kept, and each generation, the parents would tell the kids these stories about these Aboriginal traditions they learned from Timler and others. But in the 1950s, a house fire came through and burned the house down, destroyed the lot. So their descendants, from memory, rewrote everything down they'd been taught when they were younger, including memories of some of the maps they'd been drawn describing the stars. And it's clear when the first book was written and published by Jackson Cotton, that came several years after Plomley had published Robinson's journals. And it's very clear that he had included information from those journals. He was trying to fill in some of the gaps in his own knowledge from those journals. Well, from those journals included Plomley's interpretations. And like I said, when it comes to the astronomy stuff, Plomley is not a trained astronomer, and some of that information is wrong. You can see where that gets fed and seeded through. But those two sources are two of the only ones we have left. So what we have to do is put together this giant puzzle with these fragmented pieces. And some of the pieces don't fit because they weren't cut the right way, but you know where they belong. So both the Cotton papers and Robinson's papers, and I feel really uncomfortable using, these sort of two non-Indigenous families as the sources, but the information they got from, they're the ones who published the books. Cotton talks in his books and Robinson talks in his books about the original Palawa traditions about the formation of the world. Now, keeping in mind that Robinson was working with Palawa groups across different languages, but there are common threads, whereas the Cotton family was working with one specific community south of Hobart. And of course, before we even go into that, one of the issues is there was no actual evidence that Timler ever existed. There was no record of that. But considering what was happening in Tasmania, that's not exactly surprising. But it was also very clear from Cotton's journals that he was adding a lot of his own artistic flair to some of the stories. So it becomes very challenging. You don't have these sort of error bars in physics you can put on oral tradition. You just can't do that. So when you're looking at qualitative data and then trying to quantitatively analyze that, it becomes a whole new set of challenges. But both of them, in general, the knowledge written down by Robinson and the knowledge written down by the Cottons are generally the same. The sun was considered a man, the moon was considered a woman. They were husband and wife in the beginning, and they rose and set together in the sky. But the wife began slowly moving away because she couldn't keep up with her husband. So in order to encourage her to keep up with him, he would illuminate more of her each day, which is interesting because it's one of the few Aboriginal traditions or indigenous traditions from around the world that specifically say the moonlight we see is reflected sunlight. Regardless of that, there's this tradition about how they move across the sky. They have 2 children the next day, or over. A lot of these things are described in days. It's not too far, I think, from the biblical descriptions, which is probably the influence of the Quakers and George Augustus Robinson being a religious man. They did have a bit of that influence in there. But they described how Parnuan and Venna had 2 children. They had Dromardine and Moani. Moani became the great South Star, the star that never moved. And Dromardine, born the next day after Moani, was a gentle giant. He was also an extremely bright star in the sky that was placed halfway between his older brother and the 2 parents. There's a whole lot more to the narratives. There's stories about the brothers fighting with each other, sibling rivalry, coming down to earth, creating landscape features. We're not going to get into all those gory details because what we're looking at is this idea of the great South Star. So these come from the Cottons. They say the following day, they say the sons, but they're talking about the sun and the moon, had the firstborn Moani, who was considered strong, and they placed south in the southern sky over the ice cap. Now, these old traditions talked about icebergs being around the island, and they also talked about actually not being an island that was connected to mainland Australia by a thin strip of land. But there were ice caps around. And Moani was this bright star in the south that didn't move. And then Dromardine was born, and they placed him halfway between themselves and Moani. When we look at Robinson's journals, we see some other things come out of that. He says this island, he regarded the island was settled by immigrants from a faraway country. They came on land, and that the sea was formed afterwards. He says there's little doubt in his mind that the island of Tasmania was first peopled by people from New Holland, of course, that being mainland Australia, by way of Wilson's Prom, then going across the straits. And he said that, we ought to know that Van Diemen's Land might at some early period have been joined to New Holland, in which case the tradition would be true. Well, what tradition is he talking about? Well, both of these, oops, I think I actually missed that one. Sorry, missed that slide. He says, just before this, there's a lot of traditions. He said, all the people here keep saying that Tasmania wasn't an island. They said that long time ago, Tasmania was part of the mainland. It was connected by a land bridge. He says, this is really odd. We don't know what this is about. You have to realize back at that time, the idea of sea level rise wasn't common knowledge. Most people didn't know about that. They're like, well, it's an island now. How could it have been connected in the past? So they're trying to figure this stuff out because they're like, well, all the people are saying that Tassie was connected to the mainland. Of course, they didn't say Tassie, Van Diemen's Land, whatever, was connected to the mainland. If that was the case, then I guess these stories would be true. Cotton talks about that as well from the elders he'd learned from, specifically Timler. And he actually gave some of the apparent traditional names for these places. And he talks about this land to the north that was swamped by the Great Sea flowing in. And he gives the names of some of the different locations. But both Cotton and Robinson mention numerous times in their journals, their notes, and the stories about this great flowing of sea that came in and created the islands and made Tasmania itself an island. And with the Cottons lived a medical doctor named John Fordyce Story. So he lived as a bachelor with the family in their home throughout much of his life. And he had been with them learning about the star knowledge from Timler, and he became completely obsessed with this idea of a great southern star, which he believed was the southern equivalent of Polaris. So what we're looking at here are two different bits of information that we can date independently. We can look at when is the last time that Tasmania was connected to the mainland. That takes us to the geochronological side of things. And then there's the astrochronological side of things. What is this great South Star? What is this all about? And this is the research that I've been doing with several colleagues. I've been working with Professor Patrick Nunn, who is a geographer at the University of the Sunshine Coast. I've been working with Rebe Taylor, who is a historian in Tasmania. Michelle Gandervert was one of my honor students who did her whole thesis in Indigenous Studies on Tasmanian Aboriginal astronomy, and a few other students who've been working with our group. We're also working with a couple of Palawa elders, Greg Lehman and Auntie Patsy Cameron. We're kind of going through the paper now that we're about to publish, or about to submit for publication, and having a look at that. So two different lines of evidence, geochronological and astrochronological. I'm going to spend a little bit of time on the geochronological, but not too much, because it's the astrochronological that becomes the real challenge. We know the sea levels have risen. Geographers have been able to measure this fairly well. The presence of a land bridge connecting Tasmania to the mainland is on the order of 14,000 years old. This is a great website organized by Monash. It's called Sahul Time. You can actually go back over the last 100,000 years, and this bar at the top shows you the sea level changes, and you can zoom in. I've just zoomed into the southeast corner of Australia, but you can look at this globally and see how the sea level rise over the last 100,000 years has impacted the shape of the continents as we see them, the shape of the land masses as we see them. And archaeologists have deduced that when humans first came to Australia, there were two land masses, Sahul and Sunda. Tasmania, mainland Australia, and New Guinea were all one land mass, and Southeast Asia was another land mass. And there was a body of water that humans had to cross to get from one point to the other. Of course, many Aboriginal cultures have their own traditions about how they've always been here, but there are also cultures who say we came from a far-off land to the north. And the way those traditions describe themselves indicates a memory of that really early passage. We're talking, 60, 70,000 plus years there. That's, for a lot of people that raises eyebrows, but it shouldn't. When you learn about the mechanics of oral tradition and how it works, it's not really that surprising at all. But you can see during the last ice age, the sea levels were incredibly lower, up to 120 meters lower than they are today. And then there was this rapid increase. So Tasmania was connected to the mainland and around on the order of 14,000 years ago, it began to get cut off a bit. So this is a graphic that Professor Patrick Nunn contributed on his section of the paper. So we're looking at what are the very last vestiges of this land bridge. What's the very last time where it literally completely covered everything going back in time. And you get this sea level change of around 11,900 years ago. It's like the last possible time, based on all the scientific evidence, that you're going to be able to have Tasmania being completely cut off. You can no longer walk across the land bridge at all, just shy of 12,000 years ago. So this idea that an oral tradition could even go back that far shouldn't really be surprising, because Patrick Nunn and a linguist named Nicholas Reed published research a few years ago showing that the oral traditions from Tasmania are not unique. In fact, all around Australia, you have these traditions about the land being flooded by the rising seas. Port Phillip Bay, for example, was. And there's traditions that talk about landscape features that are underwater that you can't see now. And when you do your dive and you do your surveys, you can see those places. Those used to be land. The Torres Strait itself used to be a land bridge connecting Australia with New Guinea. Of course, when Patrick Nunn and Nicholas Reed published this paper, they didn't know about the Tasmanian stories. This is actually new information that wasn't included, I should say, in that initial analysis. So you can see stuff from all around Australia, and most of those go back to about 7,000 to 8,000 years, because that was sort of the last final bit of that land, that sea level rise. But Tasmania, of course, goes back much further than that. So what about the astrochronological examples? What about this analysis? So the geochronological is pretty well set. That's been studied quite a bit, tons published on that. Nothing has been published about the astronomy side. But what is this? What are we looking at? How can we go about doing this? Well, when you look at the other elements of the traditions, because they talk about this multiple times, but just little fragments here and there, you're just getting little snippets of these oral traditions, it becomes very clear that the two brothers, Dromedary and Moani, are the two brightest stars in the sky, Sirius and Canopus. Sirius being the brightest, Canopus being the second brightest. And when you're in Tasmania, when you're here in Victoria, you look up, those two stars, when they're high in the sky, are very prominent. They're towering overhead. So when you look at the traditions, going through the analysis, which we're going to go through a bit of that now, you look and you say, well, okay, well, Canopus seems like a better candidate for Moani, Dromedary, and Sirius, and placing Dromedary between Moani and themselves, the parents, the sun and the moon. Well, what would you use to measure the path of the sun and the moon? You use the ecliptic. And when you look at that, you find that Canopus, that distance, that angular distance between Canopus and Sirius is very close to the distance between Sirius and the ecliptic. That seems to fit. But there are some problems in that, because when Robinson was writing this stuff down and when Plumley was translating it and analyzing it, I should say transcribing it and analyzing it, they got bits of information wrong. And those mistranscriptions on their part, those mistakes in their analysis have been passed down to the point where there's a huge narrative where they've said those two were flipped around. That Dromedary is the star Canopus, and Moani they didn't know. Now, here's one of the traditions that was written down by Robinson. That Dromedary is the bright star seen in the south. Wordy says he comes out of the sea because from Bruny Island, he must necessarily do so. Now, wait a minute. Just said Dromedary, or said Moani was a great star in the south. What's going on here? Why the confusion? This is one of the questions we had. We go back and you look at Robinson's original notes. There were a number of places where he wrote Moani and then scratched it out and put Dromedary. He seemed to get confused about these two stars. There were several cases in his notes where he went through and did that. And then he's trying to figure out what these stars are. And then Plumley's trying to figure out what they are. And they actually wrote them down as Dromedary being Canopus and Moani being some unidentified great south star. So if you've got a star, a great bright south star that doesn't move, what does that imply? What does it imply? Where in the sky are you going to see a star that doesn't move? South celestial pole, right? We got Polaris, which is only half a degree away from the north celestial pole. You know, so when they're looking at this, they're trying to figure this out, and they're having these challenges. You know, there's another passage that Robinson writes in August of 1831 that the Aboriginal people of Bruny Island pointed out two stars lying towards the south, east of Orion's belt, and they said these were Dromedary and his brother, Moani. Well, curiously, in the notes, they actually say these are Betelgeuse and Sirius. But when you look at the descriptions and you start to piece these different fragments together, something emerges from that. And that's that the analysis of Robinson and Plumley are wrong. And it's not too hard to figure out because they get a lot of the astronomy stuff. You know, they misidentify things, they get bits of information wrong. And if you're someone like me, an astronomer working in the world of anthropology and archaeology, I don't mean to bash anthropologists and archaeologists, but if you don't have training in astronomy, it's very easy to conflate ideas, mix things up, call comets meteors, call stars constellations. Well, so what? They're all the stars. It doesn't matter. Well, it does matter. It matters a lot. Number one, it matters because you're often working for these communities and giving knowledge and information back to the elders. The elders see this knowledge has gone through this rigorous process of academia, and they expect that what they're getting back is accurate, that it's correct. And oftentimes that is not the case. I think about half my academic career is going through and fixing up all the stuff ups and all the confusion. Because not only what happens is you're getting the aspects of the traditions wrong, the specific stars do matter, but also you're missing things in those knowledge systems that actually can impact and change the history and philosophy of science. Case in point, variable stars. Pulsating variable stars like Betelgeuse, Antares, Aldebaran, those are credited as being discovered by Herschel in the 1830s. having discovered the variability of Betelgeuse. But in the same time in the 1830s, in Australia, Aboriginal traditions are being recorded that talk about these stars gradually changing in brightness over time. So something that Western science discovered in the 1830s was already long known and long included in the knowledge systems of Aboriginal people of Australia. There are a plethora of examples like that. So what I'm getting at is it's really important that we ensure that this knowledge is accurate and correct. But of course, if you look at the description, it perfectly describes Canopus and Sirius. Now, they were having a lot of difficulty with this because they were having a problem identifying Moani. So Jackson Cotton wrote down that Timler, this was the Aboriginal elder, told the doctor, that's John Fordyce, that Moani, the great spirit, had lived in the sky before he fell to the earth, and he had been the only star that didn't move. The doctor asked where in the heavens the star was, and the elder laid down 2 spears in the ground at an acute angle. He drew 5 crosses in the sand on or near the spears and gave them the traditional names. At the points where the spears crossed was Moani's position. So what Story had done is he'd drawn the diagram on paper. He added a couple of extra stars because he's trying to figure out, well, what's the actual equivalent? So he's being told what it looks like. It's sort of being drawn in the sand on the ground. He's not outside looking at the stars. So he's trying to figure out what it is, but he has some ideas. So he puts in these, so these are the 2 spears where they cross as Moani. The question marks are stars that his father, or this Jackson Cotton, his grandfather, tried putting in himself. And then it's very clear that Jackson Cotton actually drew information from Plumley's analysis, for example, where it says Dromedine Canopus and Piminer Betelgeuse. Didn't actually say what those stars were. But in Plumley's analysis, he tried doing that. But he was still having a hell of a time trying to figure out what's going on because it didn't make any sense. Where is Moani? Why is this a problem? There is no great south star. There are no bright stars anywhere near the south celestial pole. In fact, Alpha Centauri is the closest first magnitude star to the south pole, south celestial pole. But there's something interesting that comes out of the traditions. The traditions don't independently talk about the sea level rise and independently talk about the astronomical traditions. They talk about them together. They say before the seas arrived, Moani was the great south star. They actually say in the traditions, they link those together. They give you a new piece of information. Now look at 2 totally separate things and trying to fuse them together. You actually get the traditions that say before this time, this was the case. In the ancient traditions, Moani was a great south star. Moani is not a great south star today because we don't have one. So what does this mean? How do we go about trying to analyze and understand this? Well, when you go back to 1831, which of course hasn't hardly changed compared to 2021, you go back and look and you see, well, actually, if Canopus is Moani, then everything fits pretty nicely. Considering this is a map that was drawn from memory, the stars in Orion do match up. The stars in Canis Majoris do match up pretty well, not exact, but they're pretty damn close. And they do indicate that Canopus is Moani, and from the traditions, that makes sense. From the other descriptions they talk about, that makes sense. They also talked about Dromedine being a gentle being with blue skin, blue eyes, and a white hair. This is sort of the anthropomorphized version of Dromedine, and that he dwelt in the Milky Way. That's how Timler described him. Now keep in mind, when they're talking about something being in the Milky Way, they're meaning within the visual band of the Milky Way. They're not talking astrophysics where we're all in the Milky Way. They're talking within that visual band of the Milky Way. Well, both Canopus and Sirius are the right kind of star. They're both white stars, bluish white stars. And Sirius definitely lies within the plane of the Milky Way. Again, Dromedine is Sirius and Moani is Canopus. Makes perfect sense. So what we need to do now is we need to say, well, let's wind the clock back to when Tasmania was last connected to the mainland. Where were these stars in the sky? So we know that the stars themselves change in position from our point of view as we're all moving around the center of the Milky Way. So when you calculate the declination of both Sirius and Canopus, using measurements of their proper motion and their radial velocity, which their radial velocity to and from has hardly changed. The change in brightness is negligible, so we can pretty much ignore that. But when you look at these two stars' declinations, you realize something quite interesting. Canopus becomes a very southerly star. It's not on the south celestial pole, but it's within about 10 degrees of the south celestial pole. It might seem like a lot, but put your fist out at arm's length, and that's 10 degrees. So basically, you put your hand like a surfer symbol. Within that circle is where that first magnitude bright star is going to be. So it's just doing little loops in the sky. I mean, yes, technically it's moving, but for all practical intents and purposes, when you look around at other stars that are flying across the sky, that star really isn't moving much. You can pretty much say it isn't moving. Interestingly, when did Canopus reach its minimum declination? Right at the time that Tasmania was starting to be separated from the mainland by rising seas. So we've done the basic analysis, roughly 14,000 years ago is almost dead on, exactly when Canopus reached its southernmost declination. There's different levels of that come a little bit later. So you've got a terminus post-quem and a terminus ante-quem. You've got a boundary within that time period of when Tasmania was connected to the mainland and when the star was considered a great south star. Now, for our overall analysis, we've already pretty much got a conclusion out of this. But if you want to say the earlier time period, what do you mean by southerly? Well, I would probably say something that has a declination less than -75 degrees. It's kind of arbitrary. What do you consider southerly? But something within at a declination of -75 degrees, within 15 degrees at the south celestial pole is pretty damn southerly. So we have a time period for that. And when we go back and we look at the simulations, now I've used Stellarium here, and Stellarium has used an algorithm by Von Drake that can very accurately measure the positions of stars through their proper motion, going back 200,000 plus years into the past with an error bar of I think it's less than a quarter of an arc a minute or something. It's very tiny. So Stellarium, for people working in cultural astronomy, if you don't know how it works, it can be problematic. If you're an anthropologist who doesn't know about Stellarium and you see this software, you go in and you start playing around with it, you may go to an international conference and start linking together all these oral traditions from 3,000 years ago that talk about solar eclipses occurring on specific days. And then you have to suffer the indignation of having all the astronomers in the audience go, actually, sorry, there's limits on that particular algorithm. When you go back more than 2,000 years, they diverge quite a bit. So no, your whole argument's just been crushed. However, the proper motion of these stars is extremely accurate going back that far into the past. So what this means is when Tasmania was last connected to the mainland, Canopus was, for all intents and purposes, a great south star. It just blipped around the south celestial pole by just a tiny bit over 10 degrees. It fit nicely. And then when we go back and we reanalyze this map, looking at stellar proper motion, we see the map, again, fits very accurately. This also ties in to the arguments that some people have made saying that the cotton papers are complete fabrications. Well, there's no question that elements of them have been fabricated to the degree that they've had a lot of poetic license added to them. But when you actually look at things like the star map, if they already knew this information about where these stars would be at that time, they wrote that down deliberately, you could say it was fabricated. They didn't know that. They wrote this information down trying to figure it out, had no idea what they were really looking at because they didn't really think about the stars changing position. You go back 10,000 years. They didn't think about precession of the equinoxes. So precession of the equinoxes is what makes that star appear towards the south celestial pole, plus the proper motion of the star itself. So when we calculate that graph before showing the declination, it has taken into account precession, nutation, and proper motion of the stars. So we're looking at all those orbital properties together. So the year specifically, using this algorithm, that Canopus reached its southernmost declination was 12,052 years BCE, so just over 14,000 years ago. So when you look at this information together, you look at the terminus ante quem, you look at the information from the astrochronological perspective and from the geochronological perspective, you get an absolute latest date of around 12,000 years ago, with a more realistic date being around 14,000 years ago. But like the people said, the oral tradition didn't originate at that point. It already existed before that point. That is just a way that we can find that latest possible time that those two bits of information would have coincided together. So we've got this boundary, we've got these two independent bits of information that link directly together in the oral tradition that we're able to date independently, that tie up to these oral traditions being about 12,000 years old.